So I'm going to start right on this page. Turn my speaker up too. All right, so yesterday we did what was called the ratio. Okay. All right. So yesterday we did what was called the ratio test. Do you guys remember when we did the ratio test yesterday and when we got the two problems that the test failed, where we got R equals 1? So what you would do instead when that situation presents itself is now you would run the comparison test. Okay, so this one I am going to say it is used when specified, so when asked for, which for most of these questions, we do tell you use the ratio test or the comparison test, or if your ratio test fails. So use when specified, like homework, you have a section of each, or when your ratio test fails, and the ratio test failed yesterday when R was equal to 1. Okay. So on your homework worksheet, the one that was right in that packet, I think you're going to see 2 cases on the front where your ratio test does fail, and then you'll have to do this test instead. So this one is really, really quick. So your comparison test, what you're going to do is compare the terms in your sequence that's given by the problem to a known convergent series or divergent series. So this notation I know looks very, very similar. So this first one is going to be the formula that you write from the problem. So this is going to be the formula that you write from the example that you're given. I'm going to say formula you write from the example. Okay, and in our case for this first one, if your formula is less than or equal to a known formula, we're going to be able to declare that as a convergent series. So this one is going to be a known formula that you use for comparison. So this is a known formula used for comparison. I'm going to just say used to compare. With the same power, so with the same power as n in the denominator. So in the denominator. Okay, and we're going to be plugging in your terms to do this. And this is going to be for positive terms. So comparison test is positive only. Positive only. And then we're going to compare your terms to generate whether or not these are convergent or divergent series. So if the formula from the example is greater than or equal to your known formula, then we'll be able to say that it's divergent. So you're still going to be using your patterns like you did before. And what we're going to kind of do is, again, plug in your term numbers and use them for comparison purposes. Okay, I gave you a couple little side notes in case you want them, but it's up to you. I like to do this by substituting in and looking at term numbers. But if you want to think of it like that too, you certainly can. So number 1, we're going to use the comparison test to determine whether this is a convergent or a divergent series. So similar to what you did yesterday, I'm going to look at this 2 and I'm going to go 2 over 1. And I'm going to write a formula. So I'm looking for patterns again. So A sub n equals. So on the bottom, it goes 1, 2, 3, 4. So that's just going to be n. And then on the top, I went 2, 3, 4, and 5. So I took my n value and I added 1 to it. Okay. And then what you're going to do is compare this to a very similar formula with the same power of n in the denominator. So in the denominator is a power of 1, so just degree 1. So I'm going to compare this to just 1 over, nice and basic, n. Okay, so they all are going to look just like that today. Then what I'm going to do is I'm going to start plugging in my terms. I'm going to say for n greater than 1, so I'm going to start this right at n equals 2. And we're going to plug those in and see our inequality from this. So whether we're greater than or equal to or less than or equal to. So for n equals 2. So I'm going to go 2 plus 1 over the 2. And then I'm going to compare it to this one. So versus 1 over 2. And I'm looking at the terms that would represent these series. So I have 3 over 2. And then versus 1 over 2. So in this case, my left side is going to be greater. Okay. So then what you would do is you would look up in your notes, because I know this is brand new to you, and it's looking like we have a divergent series, but I always do 2 of these. So I'll do one more just to confirm, especially if you accidentally make little math errors. I know this one doesn't have any negatives, but it's just kind of nice to be certain. So now I'm going to say, how about for n equals 3? I'm going to find this term and look at this, the comparison between these terms. So this formula would give me a 3 plus 1 over, I would have the 3, and then versus my other one, which would be 1 over 3. So I have 4 over 3 versus 1 over 3. So again, you're good to go. So we're going to say that this series is divergent. Okay, so just a little test there. I should have used the other part of the screen. I'm sorry. I don't know why I did that. All right, so next formula. And what you're going to notice with these comparison tests today is none of the comparison tests are going to use the factorials. So number 2, I'm going to start and write this one over 1. And I'm going to look to generate my formula. So I have a sub n equal to. On the top, these are all just 1, so this is going to be 1 divided by. And then what's the pattern on the bottom? What kind of numbers are 1, 3, 5, and 7? Yeah, odds, good. And what are we doing to the odds? Cube, good. Again, I'm going to give you a lot of examples today just to kind of help with that pattern portion where you're recognizing that. So this one I could rewrite as 1 cubed. So on the bottom here, when I have odds and these start at 1, I am going to go 2n and then minus 1 and then cubed. And I'm going to compare this to a formula with, once again, the same power of n in the denominator. So I'm going to compare this to 1 over n cubed. All right, so just like that. So again, my terms, I'm going to be n is greater than 1, so I'm going to start right at 2. So for my terms, I'm going to go n equal to, again, 2. So I would go 1 over, and I would have 2 times 2 minus 1 cubed versus 1 over 2 cubed. Okay. So I have here 4 minus 1, so I have 3 cubed. So this would be 1 over 27. And versus, I have 1 over 8. So I think our inequality is flipped from last time. Yep. So you're going to go this direction instead. So we have less than or not equal to in this case, just less than. So now I'm going to plug in n equals 3. and I have 1 over, and I have 2 times 3, and minus 1 cubed, and 1 over 3 cubed on my comparison formula. So I'm going to take here 1 over 6 minus 1, so 5 cubed. I'm sure you guys know 5 cubed, right? With no calculator? 125, yep. And 1 over 27. And again, that should verify. In this one, instead of divergent, we're going the other direction. So this one is going to be converges. So for homework 2, you can abbreviate those. That's not a problem. So if you want to use D's and C's, it's fine. Understand what that means, so it's okay. All right, next formula. We are looking to write. So on the top here, I have all ones. And on the bottom, I think this one's a little bit tougher to get. I have a 1, and then I'm going to multiply it by a 2. So the 1 is going to be my value of n. And then how can I get a 2? What's the relationship between all those on the bottom? It goes from 1 to 2, and then 2 to 3, and then 3 to 4. So I'm adding 1 to n. Again, sometimes that's the toughest part of these, is getting your formula. So again, I want to give you a ton of practice with that. So this is going to be a sub n equal to 1 divided by, and I'm going to go n squared plus n. And again, I'm going to compare it to a known formula with the same power of n in the denominator. So I'm going to say compare to, and again, I'm giving you nice algebraic work just so that you have justification here, 1 over n squared. Okay. So then I'm going to go n is greater than 1, so for n equals 2. And I am going to have 1 over, and I'm going to go 2 squared plus 2 versus 1 over 2 squared. So I'm looking at 1/6 versus 1/4. So 1/6 versus 1/4. So same direction as your second problem. So this is going to be less than. So then say you have n equals 3 and you're looking for that term. So I can go 1 over, and I'm going to go 3 squared plus 3 versus 1 over 3 squared. So I have 1 over my 12 versus 1 over my 9. And this is going to be larger. Okay, so this one, same deal. This one is convergent. How are those? Nice and short, actually. Yeah, compared to your ratio test, they really are. So the backside are some oddball cases, and then we start kind of mixing these up. So what's listed at the top is that sometimes your pattern does not apply to the first term. Okay, so you're going to see 2 of these. It doesn't tend to occur too often, but when it does. So I want to look at that and see whether this is convergent or divergent. Now, if I look at the top, I go from a 2 to an 8 to a 32. And those look like they have a pattern, don't they? How do I get from 2 to 8 and 8 to 32? Isn't that just times 4 on the top? But obviously it doesn't work right here. How about the bottom? Does it also not work? This would be times 5. And then this would be times 5, but this one kind of messes things up. So what you're allowed to do is ignore this one. So now to determine whether this converges or diverges, I'm going to do this one nice and quick, like what we started with yesterday. So I'm going to look for my R value. And if you remember, if R was greater than 1, this was going to diverge. And if R was less than 1, this was going to converge. So I'm going to find my ratio here. So my ratio would be equal to, and again, you can do this in your head too, but I know that a lot of you like doing things with formulas. So I would go divide my consecutive terms. Again, this works every time. This is divided by 2/5. Math, enter if you need to, and that comes back as 4/5. Okay. So again, this is geometric. So geometric has that common ratio, which is actually a nice quiz review for those of you that need to do that tomorrow too. So now continuing. So I'm going to say in my case here, R is less than 1. So therefore, this series is going to be convergent. So nice, quick, and easy. How's that one? Still good? Okay. So now number 5. And you'll see that I didn't list what test this one should be. So what you want to look at is the denominators here. The denominators represent the product of consecutive integers. What is that the definition of? Product of consecutive integers. We did some notes on it yesterday. These are factorials. So factorials. And this is going to be an automatic ratio test because that is what you're going to utilize with the factorials. Okay. So to do this formula, you're going to start right on the top. So this is a review from yesterday. So on the top here, I have a 3, I have a 5, and I have a 7. So those are going to be my odd values. So 3, 5, 7, so that is denoted by 2n plus 1. So again, on top here, my pattern is that these are odds. And again, they start at 3. Now on the bottom, you're looking for what's happening. So 1 times 2 is the expansion of 2 factorial. 4 times 3 times 2 times 1 is the expansion of 4 factorial. And then 6 factorial. So not only are they factorials, but they are even factorials. I know you haven't used this formula a ton. So even is just going to be 2n factorial. Okay, do we feel okay with the formula? Okay, again, I think that's the hardest part sometimes. Now you're going to continue and you're going to write a formula for the consecutive term, which is a sub n plus 1. So I go a sub n plus 1 equal to, and I'm going to go 2, and then n plus 1, and then plus 1, and then over, and then 2, and then n plus 1. So combine these, so 2n plus 2 plus 1 would be 2n plus 3, and then divided by 2n plus 2 factorial. All right, so now you're going to do your limit formula. So the formula states that the limit as n approaches infinity of a sub n plus 1 divided by a sub n will give you your r value. So you're going to substitute into this one. So I am going to sub in the bottom. So I'm going to go 2n plus 3 divided by 2n plus 2 factorial. And then I'm going to go time, oh, I'll do division first. I don't know if you guys are comfortable skipping steps yet. 2n plus 1 over 2n factorial. Now you keep going and you're going to do keep, change, flip. Once you're working through homework, if you can shortcut some of this, it's, absolutely fine. So I'm going to go 2n plus 3 divided by, and I'm going to have 2n plus 2 factorial times, flip it, 2n factorial divided by 2n plus 1. And now what you need to do is get rid of that factorial by simplifying it. So again, I'm going to take the larger and I'm going to basically write it out, and I'm going to think in consecutive terms and try to get this guy to cancel. So 2n plus 2 factorial will give me 2n plus 2. So that's the first number. And then just like if 5 factorial was 5 times 4 times 3 times 2 times 1, the next value is 1 less than this. So 1 less than that would be 2n plus 1. I'm still not there because I want to get rid of this. And then next would be 2n factorial. And now you're good. So this breaks into all this right here. So now I cancel this, and then you're good. So I'm going to do the limit as n approaches infinity of, we have 2n plus 3 on the top. And on the bottom, I have 3 binomials. So I have 2n plus 1. I'm sorry, plus 2. 2n plus 1. And another 2n plus 1. And I'm going to do a shortcut on this again, but I just wanted to give you another opportunity to see that in case you had questions. So now I continue, and again, I'm not going to multiply the whole bottom out. I'm only looking for the leading term because all the other terms are going to approach 0 and have no significance anyways. So I'm going to do the limit as n approaches infinity. The top is just 2n plus 3. And the bottom. Again, all I care about is what is this leading term, because everything else is going to go to 0. So 2n times 2n times 2n would give me 8n cubed. And I'm going to write it just like yesterday. And I'm going to go plus dot, dot, dot. So those are insignificant. They're not going to impact your answer. You don't need them. So you can leave them off. So lastly, I do the limit as n approaches infinity of, I'm going to go 2n over n cubed plus 3 over n cubed divided by 8n cubed over n cubed. And then I'm going to simplify this. All right, so last step, then you have an answer. So top value here, 2n over n cubed, that goes to 0. Next goes to 0. And the bottom is 8. But it doesn't matter because 0 divided by 8 is just plain 0. 0. And again, r is less than 1. So this is going to be convergent. Okay, how's that type with the factorials? Okay. And again, I know that you don't have the background knowledge with the factorial, so I tried to include a bunch of those today so that you feel okay with them. All right, so number 6. I'm going to look at this, and obviously there's no factorials here. So this one will be able to just do a comparison test. And if I look at that first value, so these are all 2 squareds, and obviously this one is not. So this is going to be another nice instance where I can just ignore that first term. So I am going to ignore that. Hold on, let me fix this for you. And I'm going to write my formula and do my quick comparison test for this one instead. So again, you're going to ignore that first term. So my comparison test. Nice and quick. So comparison test, looking at your terms, seeing if we are less than or equal to, greater than or equal to. So I'm going to go a sub n is equal to. In the top, I have a 4, 9, and a 16. So I have perfect squares, but it starts at 4. So I would go n plus 1 squared. And again, that stems from your perfect squares. And in the bottom, they're all just 2 squared. So I'm going to just write 2 squared. Then what you're going to do is compare that to a known formula with the same power in the denominator. So I'm going to compare to 1 over n squared. I'm going to throw in a couple terms, again, for n is greater than 1, and then make my comparison and declare convergent or divergent, and then done. So for n equals 2, find your terms again. So I would have here 2 plus 1 squared, and it's divided by the 4 versus my other one, and that would just be 2 squared. So I have 3 squared, so I have 9 fourths versus I have 1 fourth. And this is going to be greater than. So greater than to start. So then n equals 3, I'll do that one over here. And I've got 3 plus 1 squared over the 2 squared, so still just 4. And that is equal to, let's see, 1 over n squared would be a 9. So I have here 16 fourths versus 1/9. And again, you're seeing that these hold up. You've got greater than again, so this one is going to be divergent. How are we feeling with those so far? Okay, so the last thing I want to do now is basically review all of that we just did the past 2 days. So find some sort of space. It can be in your notebook, it can be on the back of something, but these are all review questions from when we started yesterday and did arithmetic geometric still with your ratio and your common difference, as well as your ratio test and your comparison test. All right, so I'm going to give you a bunch more examples of just everything kind of mixed up. And these examples are very similar to your Delta Math quiz this week. Okay, so if you feel confident with these, then you're going to do a great job on that. All right, so on the top here, you can call it like review or you can call it extra problems, whatever you'd like. I'm going to say additional problems. I'll say additional problems. And I'm going to start right with some nice basic ones here, just like we did yesterday. So your first category, I just want you to determine whether or not these are convergent or divergent. So convergent, oops, sorry, I'm spelling wrong here. So determine whether these are convergent or divergent. So you won't necessarily have to do your ratio test or your comparison. All right, so I'll say letter A. I'm going to give you -1/2, and let's go plus 1/4, and -1/8 plus 1/16. Okay. So you're alternating signs. So this is obviously not going to be arithmetic because there would be no way to make that happen. So this is most likely going to be geometric. You're going to check your ratios, confirm that. So if this is geometric, what I should be able to do is the 1/4 divided by the -1/2 should give me the same value as my next quotient of consecutive integers, -1/8 divided by 1/4. Okay. And it does, so we're good. So this is equal to -1/2 as well as this. So geometric, yes. So now you're going to take the absolute value of your ratio. Absolute value of -1/2 is equal to 1/2. And then right on the front of your notes from yesterday, if you have 1/2, 1/2 is less than 1. And therefore, this is going to be convergence. And again, to relate it back, these were the formulas that you did with your sum that was actually possible. This one is convergent. How do we feel with A? Pretty good? Awesome. All right, your next type of example. So how about these? I'm going to go 2, 4, 8, 16. So in this case, I'm looking for, it's obviously not arithmetic, so I'm looking for my geometric ratio. I don't think you really need a formula for this one. I think you can all see that that's just doubling. So then my R value in this case is greater than 1. So this is going to be a series that is divergent. First two, very manageable. Okay. So then letter C, following suit here, and then we'll kind of go back and forth through your tests, make sure you're comfortable. So letter C, how about, I'm going to give you 10, and then 8.5, and then a 7, and 5.5. All right, would you guys agree that this is no longer geometric? What are we going down by? Yeah, -1.5, good. So this is common difference of -1.5, which means that this is arithmetic. In arithmetic, in your notes, it's, I think it was like bullet point number 2, arithmetic are always divergent. That's it. That's all you got to say on that one. So nice, quick, and easy. Those are just like the first 3 that you did yesterday. All right, so now I'm going to mix you between your ratio test and comparison test. So we'll do some of each. The more of these you see, I think the easier it is to kind of pick up on those patterns. I'm going to flip this though. Anyone need a second? Okay, got you guys. All right, so number 2. Let's say we have here, I'm going to go use the ratio test. So use ratio test. And your examples. Let's go 1/2 and 2/4 and 3/8. And if you need it, here's one more. All right, so to do my ratio test, this is where I'm going to write my formula. So I'm going to do a formula for a sub n. And that is equal to, I go 1, 2, 3, 4 across the top, so that's n. And then in the bottom, I'm looking for some particular type of pattern. So this 4 jumps out to me. That could be 2 squared. So this could be 2 cubed. And then this would be 2 to the 4th. And then this would be 2 to the 1st. So we have 2 raised to the power of n. Then what you're going to do is write a formula for a consecutive term, which is a sub n plus 1. So a sub n plus 1 is equal to, I'm going to have n plus 1, and then I'm going to divide this by 2 raised to the n plus 1. Now keep going. You're going to do your formula for your limit to get your r value. So the limit as n approaches infinity of a sub n plus 1 divided by a sub n and that's equal to, so I'm going to go n plus 1 divided by 2 raised to the n plus 1, and then divided by n divided by 2 to the n. And then you're going to do keep, change, flip, and try to cancel terms because it makes it easier. So when I do my keep, change, flip, I'm going to have n plus 1 divided by, we did this yesterday, but again, I wanted to hit on it again. Right here, I'm going to distribute this instead, and I'm going to write it as 2 to the n and 2 to the first. Because if I look ahead, that's going to allow those to cancel right there. Okay, so just a helpful little rewriting strategy. So now I can cancel my 2 to the n, my 2 to the n, and then I'm left over with, so I'm going to come over here and delimit as n approaches infinity of n plus 1 divided by 2n. And again, I'm going to take every single term and divide it by the highest power of n that I see. So 2n divided by n. So continuing, my first term here, the n's are simply going to cancel and I get 1. 1 divided by n approaches 0. And on the bottom, I'm left with 2. So r is equal to 1/2. Therefore, r is less than 1, and my series converges. How are we feeling with ratio tests? Pretty good? Awesome. So a couple more examples. Again, I feel like the more you see them, the better. So I picked this comparison test one just so that you have a chance to recognize this pattern, which I don't think has come up yet. So number 3 is going to be a comparison test. And remember, comparison tests, you're not going to see the factorials. So comparison test, and I am going to go here, 4/5 versus 4/7 versus 4/9 versus 4/11. So I'm going to start and write my formula. So my formula says a sub n is equal to, obviously the tops are all 4s, but what I wanted to kind of discuss is the bottom. What kind of numbers are 5, 7, and 9? They're odds, yep, but it doesn't start at 3. So the common pattern that you have written in your notes is when we start at 3 and when we start at 1. So odds when we start at 3 was the expression 2n plus 1. So now because I'm starting at 5, I have to add on 2. Okay, so you can still do that. I just want to make sure you knew that. So this expression down here is going to be 2n plus 3 instead. Okay. Now I'm going to compare this to a known formula with the same power of n in the denominator. So I'm going to compare to 1 over n. And then again, I'm going to think terms where n is greater than 1. So I'm going to say, how about n equals 2? So I'm going to go 4 divided by 2 times 2 plus 3 versus, and then 1 over the 2. So I have 4/7 versus 1/2, where 4/7 is going to be larger. So then I quickly throw in the 3. And again, this is my algebraic, my testing. So 4 divided by, I'm going to go 2 times 3 plus 3 versus compared to 1/3. So I'm going to compare 4 ninths to 1/3, in which that is slightly larger. So this is going to be divergent. All right, how are we feeling on those? Pretty good? Okay, I'm just gonna give you 2 more, or maybe just one, it's up to you guys. So I don't want to give it away. See if you recognize what test this needs to be. I'm gonna leave it off. Number 4, I think you will. You're gonna go 1 plus 1 divided by 1 times 2 plus 1 divided by 1 times 2 times 3 plus 1 divided by 1 times 2 times 3 times 4. What's occurring in the denominators? Factorials, perfect. And again, I know it's brand new to you, that's why I wanted to kind of give you a bunch of them. So your factorials should be your ratio test. Ratio test. We have the factorial again. All right, so I'm going to go over 1. So this is 1 factorial. This is 2 factorial. This is 3 factorial and 4 factorial. So I have a sub n is equal to 1 divided by, actually this one's easy, n factorial. That's all you're doing on the bottom. Now you're going to write a formula for a sub n plus 1, and then you're going to do your limit. So this is equal to 1 divided by n plus 1 factorial. And again, just another problem to practice simplifying those factorials. So now I do my formula. So the limit as n approaches infinity of a sub n plus 1 divided by a sub n is equal to 1 divided by n factorial divided by 1 divided by n plus 1 factorial. And then I'm going to do keep, change, flip, and simplify. So I have a 1 over n factorial. Oops, I'm sorry. Why did I do that? I flipped these, didn't I? I'm sorry, I got ahead of myself here. N plus 1 factorial, I'm sorry. And then this one was n factorial. There we go, let's fix that. So this one was n factorial. I think you guys would have caught it if I gave it another second. All right, so this one is 1 over n plus 1 factorial times, flip it, n factorial divided by 1. They all do kind of start to look the same after a certain point. So then what you're going to do is take your larger factorial and start breaking it down, because a factorial is just the product of consecutive integers. So you will be able to cancel the 1 on the top too. So I'm going to take this and simplify it. So this n plus 1 factorial is n plus 1 and then n factorial. And again, you just go right down the list. You think 6 times 5 if it was a number. Cancel, cancel. I am left with the limit as n approaches infinity of 1 divided by n plus 1. Then you're going to take each term and again divide them by the highest power that you see. And then this is n divided by n plus 1 divided by n. So this goes to 0. That simplifies to 1. And then that term goes to 0 as well. But 0 divided by anything is just going to be 0. So this is an example that converges. So converges. All right, I think I'll stop there and make sure that you understand what the plan is for tomorrow.